It's a model system that I, as a high school student, took to sea urchin embryos at Cal State University of Northridge um, developmental biology laboratory, and tried to recapitulate the same system using Dr. Becker's instructions and his advice and electrodes. So I created a system in which I looked at the cell division of sea urchin embryos and actually found windows of current ranges in which, by different orders of magnitude or different amounts of current, I could cause these sea urchin cells to reverse their progression, reverse their cell division. Normally a cell divides into one cell into two into four into eight into 16, etc. And I could make these go backwards at the lowest current levels. And as I progressively increased the current, then by orders of magnitude, I saw different effects on cell division. And then I could slow cell division at the next order of magnitude. Then I could halt it at the magnitude after that, and then the magnitude after that I could speed it up. So there was actually a dose-dependent effect depending upon the amount of what we determined later was silver ions that we were injecting electrically into the microenvironment of these sea urchin embryos. And even at that time I thought, well, how useful this technology would be to geneticists who might want to just look at the DNA at a particular phase or a particular cell stage, like the 4-cell stage or the 8-cell stage. And this was a technology that could halt a cell at that cell stage so that they could just look at the DNA expression at that cell stage. So electromagnetic medicine, obviously, you can see, can be a useful tool for research and for, the clinical application. And where it's making its inroads nowadays is in focused niche arenas. For example, when I used to assist in the OR operating room, I was with a transplant surgeon who was head of transplant surgery for one of the University of California schools, and he actually had a handheld device that when he pushed the button, we were dealing with a bleeder, which was some bleeding from a small artery, and he just pushed a button and he had a handheld device in his hand, and all of a sudden the bleeding stopped. And so I looked at him and I said, must be a resonant frequency hitting one of the enzymes in the clotting cascade, correct? And he nodded his head and said, yes, that's right. And so you can see that electromagnetic medicine in the mainstream, like in bone healing or in surgery, in stopping bleeding, is being used in very precise and very focused ways, but it has broader application, broader potential, some of which I'd like to introduce you to. So this journey that I've been on has been a personal journey, motivated primarily from my desire or my hope that it could provide a solution in the context of brain degenerative diseases like Parkinson's, which my father had. And specifically, I was hoping that I would be able to find something that would reverse his illness. And so when I was at Harvard, I in some of my coursework and in some of my homework assignments, specifically tried to focus on different aspects of electromagnetic technology that could be applied to the diagnostic side or the therapeutic side of scientific, or medical application. And so I looked at everything from vibrating electrodes to measure the local voltages around cells, or the flux of calcium ions crossing the cell membranes. And I looked at magnetic field stimulation of different parts of the brain for activation of different parts, different areas or different neural networks. And it was a very fascinating time for me because I got introduced to a lot of new theories and new ideas in the area, in the field of electromagnetic medicine. And I started conversing with other theoreticians and who started referencing me or in their papers. And so, it's still early in my career, but I hope I can shed more light on the potential for this technology, because I have been, after 22 years, I've been able to see that it does have great potential, and hopefully science can take the time and invest the resources in documenting its efficacy according to accepted standards, which means that in clinical studies the results are statistically significant. And right now that's something that would be very beneficial for the evaluation of this technology, and something I'm trying to be a part of. So the technologies I started to get exposed to at that time in college, one in particular sort of drew off of some ideas that I was playing with even before college. And one of the things that I looked at was just personally was the vibration of molecules. And I had taken water as a ball and spring model, just looked at it from that standpoint, as the oxygen and the hydrogen as two balls on a spring, and computed what frequency it would take to split that bond, because I was interested in creating hydrogen or creating oxygen from water. And those early calculations with just high school physics actually are good enough to predict some of the frequencies that most people nowadays use quantum physics and good math, better math, to actually figure out the resonant frequencies of water in order to generate hydrogen and oxygen. This one application using light is called photodissociation. And so when I looked at some of the ways in which electromagnetic fields were being applied, I saw that one way, which seemed very straightforward and very understandable, was using sort of radio waves to target viruses and shatter them, much the same way an opera singer might sing a note in such a powerful, sustained way at the resonant frequency of that crystal glass that the crystal glass eventually shatters. And when you look at viruses, they're very geometric. They're exactly resonant cavities. And so this is a way of understanding how electromagnetic energy can be used, much like a beam, to target bacteria or viruses or yeast or fungi and treat them as resonant systems, just by the fact of their dimensions, their structure, and then shatter them the same way an opera singer might shatter a crystal glass. And this was pioneered by a gentleman named Royal Raymond Rife in the 1920s and 30s.